The substitution method should be used when there's an isolated variable. This means a variable has a coefficient of 1 and is alone on one side of the equal sign. We talked about systems of equations. This is a second method used to solve a system of equations. So we're going to solve this system using substitution. I look at my two equations. I have x equals 3y, and I have x plus 3y equals negative 32. If I look at the bottom equation, I do not have an isolated variable. Yes, x and y have coefficients of 1, but neither one of them is alone. I look at the top equation. I have x equals 3y. Well, x is isolated. It has a variable. It has a coefficient of 1, and it's alone on one side of the equal sign. So that means that x is equal to 3y. That means anywhere I see x, I can really replace that with 3y. So to do this problem, I can take the green x here, and the 3y, and I can substitute the 3y into x. By doing this, okay, see how I now have 3y plus y equals negative 32? Right, that initial equation was x plus y equals negative 32. So all I did was change that first x with 3y. The reason we do that is because now I have an equation with just y's. I have a single variable equation, which we know how to solve. Step 1. Notice x is a variable that is isolated, and substitute 3y, which equals x into the second equation for x. Then we solve for y. So now that I have this alone, I can just solve this. 3y plus 3y is 4y. 4y equals negative 32. Divide each side by 4. These cancel out. We have y alone. And negative 32 divided by 4 is negative 8. Questions so far?
No.
All right. All right. So step 2, now that you know the value of one of the variables, you can choose one of the original equations to substitute it back into and solve for the other variable. So if I take x plus y equals negative 32, which is one of the original equations, and I substitute negative 8 in, because I now know that y equals negative 8. So I'm going to substitute negative 8 in for y. So I have x plus negative 8 equals negative 32. That's a one variable equation again, but this time with x. I can solve that. I add 8 to each side. It eliminates from the left side. Negative 32 plus 8 is negative 24. So now I have that x is equal to negative 24. Remember, the answer to these problems is a coordinate, right? It's the place where the lines intersect. I didn't graph these, but I did find a coordinate. I found the coordinate of negative 24, comma, negative 8. Remember, coordinates are written as x, comma, y. The last part is to check. It says use the other equation to check your answer for the values of the variables. Because I use x plus y equals negative 32 to solve for x, I'm going to use the other equation to do the check. The other equation was x equals 3y, right? So I'm going to substitute negative 24 in for x, and negative 8 in for y. So 3 times negative 8 is negative 24, and negative 24 equals negative 24. Therefore, my answer is negative 24, negative 24.